Alright, let's say we have the exponential equation 5 to the x equals 25. Obviously, you can just tell that this x equals 2. But what if the numbers are too big or they're hard to just solve or think about it in your head? Well, there's this exponent law which says if you have an equation on both sides where the base is the same, so let's say a is the base to the x equals a, since it's the same base, whatever this is, let's just make a question mark, x is always going to equal this. So let's say in this example, 25, although right here is the base, we can manipulate it. 25 is another way of saying, so 5 to the x we have here. 25 is the same way as 5 to the 2. And we took 5 because we want the same base. So now since the same base, we have same base on both sides, we can just cross them off and just equate the exponents. So now all you can just look at is the x and the 2 and say x equals 2. And that's right because 5 to the 2 is 25. Alright, now we have 2 to the x equals root 2. So we can use the same method we used as the last question. So how do we make both sides have the same base? So I think it would be easier to make root 2 have the same base as 2. So root 2 is the same way of saying, root 2 is the same way of saying 2 to the 1 over 2. Because if you remember, the denominator is what you're square rooting it by, or it doesn't have to be square, whatever. If it was a 3, it would be cube root, and the numerator is what is on the exponent. So in this case, technically there's a 2 here, but if it's a 2, you're not supposed to write anything there. So root 2 is equal to 2 to the 1 over 2. So we have 2 to the x equals 2 to the 1 over 2. And now since we have the same bases, we can just cancel them off and only look at the exponents. So now we have x equals 1 over 2. Okay, and now let's do the last example that are similar questions like these. So 7 to the x plus 1 equals 343. So we want to get 7 as the base on both sides. And we also know that 343 is equal to 7 to the 3. So now we can just replace this, and now we have 7 to the x plus 1 equals 7 to the 3. Now we can cross off the bases, but this time we just have to do one extra step. So we only look at the exponent, so now x plus 1 equals 3. Subtract 1 on both sides, and now we have x equals 2. Okay, number 4 takes a couple more steps. So here we have 12 times 3 to the negative x equals 4 over 3. So the first step is not to multiply these two together. So when you don't have the same base, you can't multiply these together. So 12 times 3 to the negative x is not 36 to the negative x. You can't do that. So, but what we can do is divide 12 on both sides. So once we divide, we're left with 3 to the negative x equals 4 divided by 3, all divided by 12 is 4 over 36. And if you simplify that, that turns into 1 over 9. Okay, and now we're left with the easy problem again. 1 over 9 is the same as 3 to the negative 2, because if you remember, when you have a negative exponent, you have to bring it to the bottom. So 3 squared is 9, but since it's negative, it's 1 over 9. So we can just say 3 to the negative x equals 3 to the negative 2. And we take off both bases, and we have negative x equals negative 2. And if we take off negative 1 on both sides, we'll have x equals 2. Alright, so the next question we have is, this time it's not so simple. There's multiple terms, and yeah, there's a couple more steps. So first thing I would do is I see 2 to the x, which is the most simple base, and I also see 4 to the x, which can be simplified to get 2 to the x. So 4 to the x is the same as 2 to the x squared, because if you remember, when an exponent is exponentiated, you multiply together. So x to the 2 is actually 2x, minus 6, this can stay the same for now, plus 8 equals 0. And now there's a really neat trick to easily solve this and do a problem that you've probably done hundreds of times. So you see 2 to the x and 2 to the x here. So if that should remind you that you can do a substitution here. Let's just say we have 2 to the x equals a. And I'll show you why I'll make it a. So if you replace 2 to the x with a, this becomes a squared minus 6 times a. This time now you can multiply because technically it's just a single variable. Plus 8 equals 0. And now that should look very, very familiar to you. Just a simple quadratic equation. So now we can just simply factor this. So a is 4 and a is 2. But don't be tricked. That's not your final answer. Because remember, a is not x. A is actually 2 to the x. So what you're saying is 2 to the x equals 4 and 2 to the x equals 2. So 2 to the x equals 4, well that's just simply x equals 2. And 2 to the x equals 2 is just 1. Because anything squared, or not squared, anything to the 1 is the same thing. So x equals 2 and x equals 1. Alright, so question number 6 is similar to question number 5. We can use the same exact technique. So once again, here the simplest base is 3 to the x. So we can make 9 to the x equal 3 to the x. So we can do the same thing. So 3 to the x squared minus 12 to the 3x. We can't do anything there. Plus 27 equals 0. Now let's do the substitution again. And the easiest way to find what to substitute here is usually just the exponent. Or usually whatever is squared, because that's what turns it into a quadratic equation. So 3 to the x is what we're going to make it the substitute, equals a. So a squared minus 12a plus 27 equals 0. Now we can just factor this again. So now we have a equals 9 and a equals 3. But don't forget, a is equal to 3 to the x. So 3 to the x equals 9. And 3 to the x equals 3. And coincidentally, this gives the same answer as the last question. Because 3 to the x equals 9. X equals 2. And, oh, this is a 3. 3 to the x equals 3. This also gives 1. So x equals 2 and x equals 1 once again. Alright, so the last question we'll do is 49 to the x plus 1 equals 2 times 7 to the x. So this one, the only thing that's changed is one of the terms is on the other side. So let's just move it back. So we have 49 to the x, and let's just move this back, so it's going to be minus 2 times 7 to the x plus 1 equals 0. And now I see that 7 to the x is the simplest base, so we can make 49 to the x equal 7 to the x squared minus 2 times 7 to the x plus 1 equals 0. So now we have 7 to the x equals a, because that's what's being squared. So we have a squared minus 2a plus 1 equals 0. So if we factor this, we'll have 1 and negative 2, negative 1. So we have a as 1. So now we can say that 7 to the x is a, because that's what we substituted it with. So 7 to the x equals 1. And if you know your exponent laws, anything to the 0 is always 1. So there's another rule, x to the 0 is always 1. And in this case, not x in this case, but in this case, x is 7. So 7 to the x is 1, x is going to be 0.